The hybrid multifunctional photoelectrocatalyst consists in the integration of light-harvesting solid materials with water oxidation molecular catalysts and CO2 reduction molecular catalysts, so they can work in harmony, generating the transformation of sunlight into a CO2-based syngas. The photoabsorber provides the necessary photovoltage to drive the overall reaction. In SunCoChem, we are using solid metal oxide semiconductor materials. However, using just a single photoabsorber, the voltage is limited because of the band gap of the material. That means that a single photoabsorber alone will not be able to drive the real reaction. In SunCoChem, we have designed hybrid photoelectrocatalysts that are able to provide the necessary photovoltage for the overall chemical reaction. The device will harvest the energy of the sun to produce syngas, using captured industrial CO2 and water as the only raw materials. Then, the photogenerated syngas will be applied as raw material for the hydroformylation of olefins. The device will integrate all these processes on a single unit, generating the transformation of sunlight into a high-value oxochemical. One way to think about the operating principle of the system is to consider the photoabsorbers as the power component of the system. The photoabsorber provides the necessary current and voltage to drive the real reaction, and the catalyst as the electrochemical load of the system. The electrochemical load essentially tells you how fast you are driving the real reaction when you apply a certain voltage. A photoelectrocatalytic CO2 reduction system takes the sunlight, water and CO2 and generates oxygens and fuels. In SunCoChem project, we are engineering a system that photogenerates syngas that will be applied in tandem as raw material for the hydroformylation of olefins. The key materials of the photoelectrocatalytic CO2 reduction systems are the photoabsorber, that captures the sunlight and photogenerates electrons and holes and transport them to the reaction sites, and on the other hand, the catalyst that drive the electrochemical process. In our system, we have two half reactions, one water oxidation reaction that takes place at the anode, and in the cathode, where the CO2 reduction reaction occurs. So, the key materials in the overall system are the photoabsorber, the CO2 reduction catalyst, and the water oxidation catalyst. At some point, we are going to run out of fossil fuels. So, in the next century, we will need to have a different chemistry starting from other types of raw materials like CO2, and by applying those concepts of artificial photosynthesis, we are going to be able to do so. SunCoChem reactor managed to do what nature is doing using sunlight and transforming this sunlight into energy. This allows us to come up with a new energy conversion scheme for oxochemicals production, from which we can start the transition from the fossil fuels to a solar fuels.